Hi everyone. In this video I want to explain about the introduction to logarithms. So suppose before going to the logarithms, I will explain the exponents. Suppose 2 into 2 into 2 into 2 into 2 can be written as 2 to the power of 4. That is nothing but 2 is raised to the power 4. 2 is raised to the power 4. 2 is called as the base and 4 is the exponent. Suppose 3 into 3 into 3 if you will write. 3 into 3 into 3. 3 to the power of 3 we can write. 3 raised to the power of 3. 3 raised to the power 3. Suppose a into a into a n times can be written as a into a into a n times can be written as a to the power of n. A to the power of n. And these are the just exponents. Then if you suppose 2 to the power of x is equal to what? 4 I am taking. Then what is the value of x? So 4 can be written as 2 square. And if bases are equal, power should be equated. 2 to the power of x is equal to 2 square. So x is equal to 2 is the value. And if suppose 3 to the power of y is equal to 81, how can I write this? 81 can be written as 3 to the power of 4 and bases are equal, power should be equated. Y is equal to 4. And what is 10 to the power of z is equal to 10,000 or 1 lakh I will take. So it can be written as 10 to the power of z is equal to 10 to the power of 5. So z is equal to 5. Z is equal to 5. So here we can find the values of x, y, z. In these cases, we can find the values of x, y, z. Suppose I will give that 2 to the power of x is equal to 5. Can you find out the value of x? In this case, 2 to the power of x is equal to 5. Or else 3 to the power of y is equal to 7. Can we find out 3 to the power of y is equal to 7? Can you find out? Or else 10 to the power of z is equal to 15. Can you find out the value of z? No. Yes. Not directly by using exponents. Up to now we find the values of x, y, z by using exponents. Here, so suppose 2 power x is equal to 5. I will try to find out the value by raising their powers. Suppose 2 to the power of minus 2 I will take. It can be written as 1 by 2 square is equal to 1 by 4 is nothing but 0.25. 2 to the power of minus 1 I will take. 1 by 2 to the power of 1. So a to the power of minus, already formulas you know, a to the power of minus n is equal to 1 by a to the power of n. So that is equal to 1 by 2 is nothing but 0.5. And 2 to the power of 0 I will take 1, since any non-zero number raised to the power of 0 is 1. Then if 2 to the power of 1 I will take, it becomes 2. If I will take 2 square, it becomes 4. If I will take 2 cube, it becomes 8. So where is our problem? 2 power x is equal to 5. Between 4 and 8. Answer between 4 and 8. That means x value must be between 2 and 3. X values lies between 2 and 2 and 3. X values lie between 2 and 3 and nearer to 2. Because 2 to the power of 2 is equal to 4. So 2 power x is equal to 5. It is nearer to 2 power 2 is equal to 4. So our x value lies between 2 and 3. 2 and 3. Okay. In this case, we need to establish the relation between x and 5. Isn't it or not? We need to find out the relation between, in 2 power x is equal to 5. We need to find the relation between x and 5. In this new relation, what is that? Nothing but logarithm. So nothing but in such cases we use the logarithms. We use the logarithms. So logarithm, how can you write the symbolic form? 2 power x is equal to 5 in symbolic form. So 2 power x is equal to 5 can be written as x is equal to log 5 to the base 2. X is equal to log 5 to the base 2. In the same way, 3 power y is equal to 7 can be written as y is equal to logarithm of 7 to the base 3. In the same way, 10 to the power of z is equal to 15 can be written as z is equal to logarithm of 15 to the base 10. So in general, logarithms is defined as for any a greater than 0 and a is not equal to 1 and n must be greater than 0, a comma n belongs to real numbers, then we can define a power x is equal to n if and only if, implies and implied by, if and only if x is equal to log n to the base a. X is equal to log n to the base a. So a power x is equal to n if and only if x is equal to log n to the base a. This is the exponential form and its logarithmic form is x is equal to log n to the base a. If x is equal to log n to the base a, its exponential form is a power x is equal to n. Is it clear? So just now I will give some examples. Represent 7 square is equal to 49 in logarithmic form. So how can you write? Log 49 to the base 7 is equal to 2. So 7 square is equal to 49. Suppose 5 cube is equal to 125. How can you write in the logarithmic form? Log 125 to the base 5 is equal to 3. These are the exponential form and logarithmic forms. Exponential form is given. How can you convert into logarithmic form? Now I will give one logarithmic form. Log 10,000 to the base 10 is equal to 4. How can you write it as exponential form? 10 to the power of 4 is equal to 10,000. 10 to the power of 4 is equal to 10,000. In the same way, one more example I will give. Log 0.01 to the base 10 is equal to minus 2. So how can you write as the logarithmic form? 10 to the power of minus 2 is equal to 0.01. 0.01. 10 to the power of minus 2 is equal to 0.01. Okay. So conversions, have you understood? I think so. Conversion of logarithmic form to exponential form and exponential form to logarithmic form. Now example I will take. One example, 2 power 0 is equal to how much? 1. We know because any non-zero number rise to the power 0, its value is 1. What is 3 power 0? 1. What is 10 power 0? 1. Implies what is a power 0? 1. You know that. Then apply the logarithmic forms for these exponential forms. Then what you will get? Log 1 to the base 2 is equal to 0. Log 1 to the base 2 is equal to 0 here. And here log 1 to the base 3 is equal to 0. And here log 1 to the base 10 is equal to 0. So finally what you can conclude? Log 1 to any non-zero base is equal to 0. Log 1 to any non-zero base is equal to 0. This is the first and second I'm going to explain. Suppose 2 power 1 is equal to how much? 2. And what is 5 power 1? 5. And what is 7 power 1? 7. And finally what you can conclude? A power 1 is equal to A. A power 1 is equal to A. Convert these exponential forms to the logarithmic forms. What you will get? Log 2 to the base 2 is equal to 1. Log 5 to the base 5 is equal to 1. Log 7 to the base 7 is equal to 1. So finally what you can conclude? Log a to the base a, any number to the same base is equal to 1. Unity. So these are the two things you have to remember. Log 1 to the base a is equal to 0 and log a to the base a is equal to 1. So log 1 to the base a is 0, since a power 0 is equal to 1 and a power 1 is equal to a, so log a to the base a is equal to 1. Okay, next. Solve log 625 to the base 5. Solve the value or find the value or determine the value of log 625 to the base 5. So this is equal to x or y, you can think x. And what is the exponential form here? So 5 to the power of x is equal to 625. 5 to the power of x is equal to 625. And 625 can be written as prime factors, as a product of prime factors. 5 125s are 5 25s and 5 5s. So it can be written as 5 power x is equal to 5 power 4. And then bases are equal, power should be equated. X is equal to 4 you will get. X is equal to 4. That means logarithm of 625 to the base 5 is equal to 4. Logarithm of 625 to the base 5 is equal to 4. And I'll ask one question. If log 16 to the base 2 is equal to log 16 to the base x is equal to 2, then what is the exponential form here? X square is equal to 16. Then what is x value? Root 16. So if it is root 16, what are the values of x? X will take plus or minus 4. Is it correct? Justify. They'll ask like that. So x is equal to plus or minus 4 is correct. So x is equal to 4 is correct because 4 square becomes 16. Plus 4 is correct. But x is equal to minus 4 is not correct. X is equal to minus 4 is not correct. Because already we discussed about in the definition of logarithms, x must be greater than 0 and x is not equal to 1. X must be greater than 0. Base of the logarithm should be greater than 0 and it is not equal to 1. So that's why logarithm of 16 to the base x is equal to plus 4 you will get, not minus 4. Not minus 4. Okay. Now, so we discussed already log 1 to any base is 0 and log any number to the same base is 1. And what about log 0 to the base 2? What is the value of log 0 to the base 2? Let us take this is equal to x. Then what is the exponential form? 2 power x is equal to 0. So for any value of x, 2 power x becomes 0? No. So it is not defined. Not defined. Which is not defined? Log 0 to any base is not defined. Log 0 to any base is not defined. I'll discuss some problems. Determine the values of the following. What is the value of log 5 to the base 25? This is nothing but exercise 1.5 first question in the textbook. So log 5 to the base 25 is equal to x, you can think. Then what is its exponential form? 25 to the power of x is equal to 5. So to find out the value of x, I have to convert 25 into power notation as 5 square to the power of x is equal to 5 power 1. And now a power m into a power m whole power n is equal to a power mn. So 5 power 2 whole square is becomes 5 to the power of 2x is equal to 5 to the power of 1. Then bases are equal, power should be equated. 2x is equal to 1 it becomes, and x can be written as 1 by 2. X can be written as 1 by 2. So what is the value of log 5 to the base 25 is nothing but 1 by 2. Okay. Any number you have to equate. If you want to convert into, find the value of x, you have to convert into exponential form and you can find out. And secondly, I will ask, what is the log 1 to the base 7? What is the value of log 1 to the base 7? So here what you have to think, again this is equal to sum of the value either x or y or z, anything you can think. Then what is the exponential form of this? 7 to the power of y is equal to 1. Here this side LHS 7 base and RHS 1 is the base. Then we know that any non-zero number is raised to the power 0, its value is 1. So whatever is asked in the LHS, same way you can write as the RHS with base 7 to the power of 0. So 1 can be written as 7 power 0. 1 can be written as 7 power 0. Because why you have taken 7? Because LHS 7 is there. So base are equal, what is the answer? Power should be equated. What is the y value? 0. So log 1 to the base 7 is equal to 0. Already we discussed in the beginning itself. So log 1 to any base is 0. Log 1 to any base is 0. Next, one more law I will discuss. So today actually we discussed log 1 to any base is 0. Log a to the base a is 1. Log 0 to any base is not defined. It's not defined. There's 3 laws you learn. Just now I will tell one more law. Suppose 2 power x is equal to 7. 2 power x is equal to 7. Okay. Then what is the logarithmic form of it? Log 7 to the base 2 is equal to x. That means x value is log 7 to the base 2. Now I will ask, what is the value of 2 to the power of log 7 to the base 2? 2 to the power of log 7 to the base 2. So as log 7 to the base 2 is x, I can write this as 2 power x. And what is the value of 2 power x? 7. So what I can conclude here? What I can conclude here? So 2 to the power of log 7 to the base 2 is equal to 7. 2 to the power of log 7 to the base 2 is equal to 7. So finally, in general, I can conclude that a to the power of log n to the base a is equal to n. A to the power of log n to the base a is equal to n, we can conclude. This is one more law. A to the power of log n to the base a is equal to n. Okay. Based on this law, I'll discuss one of the example. One or two examples. What is the value of 2 to the power of 2 plus log 3 to the base 2? Evaluate. This is also 1.5. Exercise 1.5, first question, last sum. So here, how can you write? It is in the form of a to the power of m plus n. 2 to the power of 2 plus log 3 to the base 2. A is 2, m is 2, plus n is log 3 to the base 2. And what is the law for a to the power of m plus n? A to the power of m into a to the power of n. A to the power of m into a to the power of n. So this can be written as 2 square into 2 to the power of log 3 to the base 2. 3 to the base 2. That is equal to 2 square is 4. And just now we discussed a to the power of log n to the base a is equal to n. So what you will get as n value here? 3. So 4 3s are 12 is the answer. So 2 square 2 to the power of 2 plus log 3 to the base 2 is equal to 12. Okay. This with the plus sign I have given. Now I will give with minus sign. So 3 cube, 3 to the power of 3 minus log 2 to the base 3. Log 2 to the base 3. What is the value of this? And here we have to go for the law a power m minus n is equal to a power m by a power n. A power m minus n is equal to a power m by a power n. So what I can write here? 3 to the power of 3. 3 to the power of 3 by 3 to the power of log 2 to the base 3. Log 2 to the base 3. 3 cube is 27 by 3 to the power of log 2 to the base 3 becomes 2. So its value is 27 by 2. Its value is 27 by 2. Simply we applied the exponential law as well as logarithmic law. And one more. 5 to the power of 4 log 3 to the base 5. Here with plus sign I have given, here with minus sign, and here into. Means multiplication. 5 to the power of 4. So how can I write this? I have to make this as single logarithm in the form of a to the power of log n to the base a. In this form I have to convert so that I can write its value as n. So here how can I write 5 as it is, base as it is, and one more law, m log a is equal to log a to the power of m. I'll discuss the laws in the next video. So m log a is equal to log a to the power of m. Based on this, the power becomes log 3 to the power of 4 to the base 5. Log 3 to the power of 4 to the base 5. As log 3 to the power of 4 is 81, as log 3 to the power of 4 is 81, so that is equal to 5 to the power of log 81 to the base 5. And if the base and the base of exponential form and logarithmic base is same, then 81 is the answer. So its value is 81. Its value is 81. So is it clear? These three type of models, very important. They are used to ask in the public examinations. Okay.